filled the gate form? Yes or no? If you have not filled, write no. If you have filled, write yes. So you might be knowing the policy that our college is bearing 50% of registration charges related to the gate fee. So if you are getting the non-zero score, that means if you are getting 1 mark also, if you are getting 1 mark also in the gate, so whatever amount you are paying as a registration charges, 50% of that amount will be reimbursed to you. So each and every student have to fill the gate form, and tomorrow is the last date for filling of the gate form. So if you have not filled the gate form, today only you have to fill that gate form, and you have to send that screenshot of filled gate form to your respective project guide. So until and you have to fill that gate form, because that gate exam is very much important as far as your further education is concerned, as well as if you are not only for further education, that means for ME Tech, if you want to have the job in the PSU sector also, as well as most of the company are preferring the gate score. So for PSU, if you see that PSU sector, so the recruitment of PSU sector is totally depend upon the gate score. So everyone has to fill the gate form, and you have to send the screenshot of filled gate form to your respective project guide. Will it be okay? So if you have not filled the gate form, today only you have to fill the gate form. So now we'll start the solving of test number 1. Okay. Before solving the test number 1, you have to give the feedback related to the test number 1 as well as test number 2. Whether those tests were easy, or those tests were moderate level, or that test were difficult level to solve those tests. How was the test? Level of test, that means easy test, moderate test, or difficult? Moderate. What about remaining student? Okay. So we'll see the test number 1. So total 47 students have attempted the test number 1. So this is the first question. Reversible Carnot cycle used for refrigeration comprises. So we are knowing that reversible Carnot cycle consisting of 2 isentropic and 2 isothermal processes. So answer D was the correct answer. Answer D was the correct answer. Then second question. Second question is nothing but, in a typical system, within which component would the evaporation of refrigerant takes place? So in a typical system, that means in Fischer system, within which component would the evaporation of refrigerant takes place? So where that refrigeration evaporate, that means where that refrigerant is getting converted from liquid refrigerant to vapor refrigerant, the answer is nothing but C, that is nothing but evaporator. Then next question is, where does the low pressure liquid becomes a gas or vapor? So where that liquid is getting converted into vapor? Option is evaporator, condenser. TX wall means thermostatic expansion wall. TX means thermostatic expansion wall, and last one is nothing but compressor. What is the answer? So you have to write in the chat box A, B, C, D. So consider this as a A, this as a B, C, and D likewise. So what was your answer? Where that liquid is getting converted into vapor? In which device? Do it fast. So answer is nothing but evaporator, because in evaporator liquid refrigerant is getting converted into vapor refrigerant. Then next one is nothing but in what state the refrigerant when it exit the condenser. That means after exiting the condenser, what will be the state of refrigerant? So we are knowing that in the condenser heat rejection process is takes place. That means after compressor there will be condenser. So because of heat rejection, the vapor refrigerant will get converted into liquid refrigerant, but pressure will be high pressure. So high pressure liquid refrigerant was the answer. So C was the answer. Then next one is nothing but the two major function of compressor are to circulate the refrigerant. That means there are two major function of compressor. Out of that, first one is nothing but to circulate the refrigerant, and second one is to compress. So that compressor is compressing the low pressure vapor refrigerant into high pressure vapor refrigerant. So if you see the correct option, so low pressure vapor refrigerant into hot high pressure vapor refrigerant. High pressure is similar to the high temperature, because after compression temperature will also goes on increasing. So option A was the correct answer. Option A was the correct answer. Then next question is nothing but as refrigerant move through the condenser, it goes from, so in the condenser when that refrigerant will move from the condenser, it will goes from vapor to liquid, liquid to vapor, low pressure vapor to a low pressure vapor, low pressure vapor to a low pressure vapor. Next one is nothing but high pressure liquid to a low pressure liquid. So what was the option? Correct answer? Answer A. That means in a condenser, that refrigerant will move from vapor refrigerant to liquid refrigerant. So answer A is the correct answer. The next dash dash decreases pressure inside the system. So in which device pressure will goes on decreasing? Compressor, condenser, capillary tube, evaporator. What is the answer? Capillary tube. That is nothing but C will be the correct answer. Then next one is nothing but the heat removal capacity of 1 ton of refrigeration is equal to. So here 210 watt, 210 kilojoule per hour, 3.5 kilojoule per hour, 3.5 watt. That is the correct answer. Correct answer is nothing but 3.5 watt, or if it will be in terms of kilojoule per minute, then that will be 210 kilojoule per minute. But correct answer is D. The next question, in which type of refrigeration system, a secondary compressor is used? So here this is related to air refrigeration system. So where we are using the secondary compressor means where we are using the two compressor. So in case of reduced ambient type air cooling system, we are not using the secondary compressor. In regenerative also we are not using the secondary compressor. In simple also we are not using the secondary compressor, but we are using the secondary compressor in bootstrap air refrigeration system. The meaning of bootstrap is nothing but increasing the pressure slowly or gradually. That is nothing but the bootstrap. So answer D is the correct answer. Then next one is nothing but which of the air cooling system is used for transportation purpose? So I have told you the application of each and every system also. So for transportation purpose, we are using the bootstrap air cooling system. So answer A is nothing but the correct answer. Then next one is related to the COP of refrigeration is 4. What will be the COP of heat pump when it will works on the same source and sink temperature? So we are knowing the correlation. COP of heat pump is nothing but COP of refrigerator plus 1. So here they have mentioned the COP of refrigerator is nothing but 1. COP of refrigerator is nothing but 4. So COP of heat pump they have asked us. So COP of heat pump will be equal to COP of refrigerator plus 1. That is nothing but 4 plus 1 5. That will be the correct answer. Then next one is nothing but in simple air cooling system, or the simple air cooling system is good for dash dash height speed. So application of simple air cooling system is for low height speed. So answer A will be the correct answer, low height speed. Then 1 ton of refrigeration is nothing but here in terms of kilojoule per minute you have to mention. So 1 ton of refrigeration is nothing but 210 kilojoule per minute. That is B will be the correct answer. B will be the correct answer. Then next one, 1 ton of refrigerating machine means that 1 ton of refrigeration means 1 ton is total mass of the machine. That is the wrong answer. 1 ton of refrigerant is used. That is also wrong answer. 1 ton of water can be converted into ice. That will be also wrong answer, because we have to either form 1 ton of ice or either we have to melt 1 ton of ice, but that should be in 24 hours and that should be from 0 degrees to 0 degrees centigrade. So 1 ton of ice can melt from and at 0 degrees centigrade in 24 hours. That will be the correct answer. So D will be the correct answer. Then next question is nothing but in refrigerating machine, heat rejected is dash dash then heat absorbed. So what will be the correct answer? In refrigerating machine, whether heat rejected will be equal to, less than, or greater than, or partially less than heat absorbed. Give the answer. In refrigerating machine, heat rejected is greater than heat absorbed, because working on the second law of thermodynamics. So according to second law of thermodynamics, it will be impossible to transfer the heat from low body temperature to high body temperature without add an external agency. So in case of refrigerating machine, we are absorbing the heat from the lower body temperature, and that lower body temperature heat we are rejecting to the higher body temperature, and to do so we require to apply the external work in the form of work supplied to the compressor, and that work is getting converted into heat. So amount of heat rejected, that is Q2, will be equal to Q1 plus W. So amount of heat rejected is greater than amount of heat absorbed. So C will be the correct answer. Then next question, in air conditioning or aeroplane, using air as a refrigerant dash dash cycle is used. So which cycle we are using in case of air refrigeration system? So we are knowing that processes which are occurring in the air refrigeration system. So first of all, air is coming inside the aeroplane. So by ramming process, so that ram air will be supplied to the compressor, where isentropic compression process will take place. That compressed air will be supplied to the heat exchanger, where constant pressure heat rejection process will be taking place. Then that outlet of heat exchanger will be supplied to the cooling turbine, where again isentropic expansion will take place, and that expanded air will be again supplied to the aeroplane cabin, where constant pressure heat absorption process will take place. So that is nothing but the, so two isentropic processes, two constant pressure heat rejection and heat absorption processes, that will take place in terms of Bell-Coleman cycle. And that Bell-Coleman cycle is also called as a reverse Breton cycle. So option C is nothing but the correct answer. Then the coefficient of performance. The coefficient of performance is always dash dash than 1. So we are knowing that coefficient of performance is nothing but it is the reciprocal of efficiency. So COP of any system will be always greater than 1. So greater than, option C is the correct answer. Then next question, the subcooling of refrigeration cycle. So here they have asked the effect of subcooling on the COP of PCRS. So because of subcooling, we are knowing that we have seen the effect of subcooling as well as superheating on the COP of PCRS, as well as we have seen the effect of suction pressure as well as discharge pressure on the COP of PCRS. So what about the effect of subcooling on the COP of PCRS? So because of subcooling, we are knowing that the COP of PCRS system will goes on increasing. So option B will be the correct answer. Because here, because of doing the subcooling, the refrigerating effect, that means amount of heat absorbed inside the evaporator will goes on increasing without affecting on the compressor work. Without affecting on the compressor work. So option B will be the correct answer. If you are having any doubt, you can ask in between. Whether you are having any doubt up to here, whether you are having any doubt up to here. If you are having doubt, you can ask me. Shall we proceed further? Okay. The next question is related to, in a refrigeration system, expansion device is connected to. Here will be the proper position of expansion device. In between compressor and condenser असतो का expansion device? कॉम्प्रेसर आणि कंडेन्सर मध्ये असू शकतो का? नो. कंडेन्सर आणि रिसिव्हर मध्ये असतो का? नो. रिसिव्हर आणि इव्हापोरेटर. So here, what is the main function of receiver? What is the main function of receiver? To regulate the continuous supply of the refrigerant which is coming from the condenser to the expansion device. So proper location of expansion device will be in between a receiver and evaporator. So option C is the correct answer. Option C is the correct answer. Then next one is nothing but the condition of refrigerant after passing through the condenser in vapor compression refrigeration system will be or is. What is the condition of refrigerant after passing through the condenser? Saturated liquid, wet vapor, dry saturated vapor, superheated vapor. So whether which process is taking place inside the condenser? Constant pressure heat rejection process is taking place inside the condenser. And because of heat rejection, vapor is getting converted into liquid. So here the correct answer is nothing but saturated liquid. Correct answer is nothing but saturated liquid, because after heat rejection, vapor is getting converted into liquid. So wet vapor will not be generated, dry saturated vapor will not be generated, superheated vapor will not be generated. So option A will be the correct answer. The next question, when the lower temperature of refrigerating machine is fixed, when the lowest temperature or lower temperature of a refrigerating machine is fixed, then coefficient of performance can be improved by. So we have seen two examples, that is COP of refrigerating machine is given by equation T1 divided by T2 minus T1. So we have seen that reverse Carnot cycle. So in case of reverse Carnot cycle, the COP of reverse Carnot cycle is depend upon T1 and T2. So when value of T1 will goes on increasing, or when value of T2 is goes on decreasing. When value of T2 is goes on decreasing, then the COP of system can goes on increasing. And for that purpose, I have given you two examples. That means consider same refrigerator which is working in the winter season and which is working in the summer season. So in which case the COP will be higher. And second example we have seen, suppose same refrigerating machine we are using for cooling of the water up to 10 degrees centigrade and for cooling of the water up to 0 degrees centigrade. Here will the higher value of COP. So here, as lower temperature is fixed, so the COP of that refrigerating machine will be increased or improved by decreasing the higher temperature. So lowering the higher temperature, that is D is the correct answer. The next one, the COP of heat pump working on a reverse Carnot cycle is T2 is the higher temperature, T1 is the lower temperature. What is the correct answer? Write in the chat box. Only 2 or 3 students are giving the answer. What about remaining students? What What about remaining student? So we are knowing that COP of reverse can sorry COP of heat pump is given by equation T2 divided by T2 minus T1. So this is the COP of heat pump. So if they have asked the COP of refrigerating machine, the correct answer might be T1 divided by T2 minus T1, because T2 is nothing but the higher temperature, T1 is nothing but the lower temperature. So D is the correct answer. Option D. Then next question. Okay. This question was a challenging question. So if you are having pen and pencil, or sorry, pen and notebook, please write down. So we'll write down the given data and we will try to solve this question. A refrigerating system operating on a reverse Breton cycle. A reverse Breton cycle is called as a कोणती सायकल म्हणतोय रिव्हर्स ब्रेटॉनला? Reverse Breton cycle is called as a Bell-Coleman cycle. So a refrigerating system operates on a reverse Breton cycle, that is nothing but Bell-Coleman cycle. So if you operates on a Bell-Coleman cycle, is used for maintaining 250 Kelvin temperature. Now here, used for maintaining 250 Kelvin temperature. What is the meaning of it? That means we have to maintain the 250 Kelvin. That means we have to achieve a temperature equal to, that is nothing but value of T1 they have mentioned. So value of T1 is nothing but 250 Kelvin. Value of T1. So write down value of T1 is nothing but 250 Kelvin. If the temperature at the end of constant pressure cooling is 300 Kelvin, which temperature they have mentioned this? 300 Kelvin is nothing but temperature at the end of constant pressure cooling. Constant pressure cooling, that is called as a, that is nothing but value of T3. So they have mentioned the value of T3 as a 300 Kelvin, value of T1 as nothing but 250 Kelvin, and rise in the temperature of air in the refrigerator is 50 Kelvin. So what is the meaning of this? Rise in the temperature of air in the refrigerator. So in the refrigerator means in the evaporator. So inlet point for evaporator is nothing but T4. Outlet point for evaporator is nothing but T1. So T1 minus T4 is nothing but 50 Kelvin. T1 minus T4 is nothing but 50 Kelvin. Out of that, we are knowing the value of T1. So what is the value of T1? 250 Kelvin. So value of T4 will be automatically 200 Kelvin. Value of T4 will be automatically 200 Kelvin. So here, as I am unable to write here because that writing option is not available on this. So I am telling you. So you have to write in your on your page. So here, up to here, up to this, we are getting that value of T1. T1 is nothing but temperature maintained inside the refrigerator is nothing but 250 Kelvin. The temperature at the end of constant pressure cooling, at the end of constant pressure cooling is nothing but point number 3, because 2 to 3 process is called as a constant pressure heat rejection process in the Bell-Coleman cycle. So end point is nothing but 3 point. So 300 Kelvin is nothing but value of T3, and rise in the temperature in the air refrigerator. So rise in the temperature in the air refrigerator means it is the value of T1 minus T4. So T1 minus T4 is equal to 50 Kelvin. So as you are knowing, the value of T1 is equal to 250. So value of T4 will be equal to 200 Kelvin. Then the net work on a compressor will be. Now what is the formula to calculate the net work on the compressor? What is the formula? So formula is nothing but, so if you see the Bell-Coleman cycle, so we have solved that, or we have derived the equation for Bell-Coleman cycle, COP of Bell-Coleman cycle, that is nothing but 1 upon RT raised to gamma minus 1 upon gamma minus 1. So during that derivation, you will see that the value of the value of net work on a compressor will be given by equation Cp into T2 minus T1 minus T3 minus T4. T2 minus Cp into T2 minus that equation will be Cp into T2 minus T1 minus T3 minus T4. That will be the equation. So we have to find out the value for Cp into T2 minus T1 minus T3 minus T4. So we are knowing the value of T1, we are knowing the value of T3, we are knowing the value of T4. But value of T2 is unknown. Value of T2 is unknown. So how to calculate the value of T2? So as in case of Bell-Coleman cycle, we are knowing that process 1 to 2 is isentropic process, and process 3 to 4 is also isentropic process. So we have derived the derivation. So during that derivation, we came to know that value of T3 by T4 is equal to value of T2 by T1. So if you refer the notes, you will get this. So T3 by T4 is equal to T2 by T1. So here we are knowing the value of T3, we are knowing the value of T4, we are knowing the value of T1. So we are able to calculate the value of T2 also. So we'll get the value of T2 as a 375 Kelvin. We will get the value of T2 as a 375 Kelvin. So after getting the value of T2, we are knowing the value of T1, T2, T3, T4. So put that value of T1, T2, T3, T4 in the formula of Cp inside the bracket T2 minus T1 minus T3 minus T4. So we'll get that, put the value of Cp, T2, T1, T3, T4. We'll get the answer as a 25 kilojoule per kg. 25 kilojoule per kg. So answer A will be the correct answer. But by mistakenly from my side, that answer B was written as a correct answer. But here answer A will be the correct answer. That is nothing but 25 kilojoule per kg. Are you getting the answer? Yes or no? Are you getting the answer? Or is it necessary to explain once again? Write in the chat box. All of you, please write in the chat box whether you are getting the answer or is it necessary to solve by using the PPT. Should I solve by using the PPT? What should I do? Write in the chat box. Getting okay. So next question: if a heat pump cycle operates between the condenser temperature of plus 27 degrees centigrade, evaporator temperature of minus 23 degrees centigrade, then the Carnot COP will be. Then the Carnot COP will be. Please write on your paper, that is by using the pen and paper. We are knowing the Carnot COP, that is COP of Carnot cycle. Or here, if a heat pump operates, or if a heat pump cycle operates between condenser temperature 27 degrees centigrade. So condenser temperature plus 27, evaporator temperature minus 23. So we are knowing the COP of Carnot cycle, or COP of Carnot heat pump is given by equation. What is the formula? T2 divided by T2 minus T1 heat pump. And if that will be the Carnot Carnot refrigerator, the formula might be T1 divided by T2 minus T1. So write down the formula. COP of heat pump working on the Carnot cycle is given by equation T2 divided by T2 minus T1. So T2 is nothing but the highest temperature. T1 is nothing but the lowest temperature. If you see, highest temperature is nothing but plus 27. So T2 value is nothing but plus 27, but that is in terms of degree centigrade. Convert it in terms of Kelvin. So 27 degree centigrade means 300 Kelvin. So T2 is equal to 300 Kelvin. And T1, that is nothing but lowest temperature. T1 is nothing but minus 23 degrees centigrade. So in terms of Kelvin, that will be 250 Kelvin. 273 minus 23. That is nothing but 250 Kelvin. Now put the value of T2 as a 300 Kelvin put the value of T1 as a 250 Kelvin. So 300 divided by 300 minus 250, that is nothing but 50. So 300 divided by 50 is equal to 6. So option D will be the correct answer. Are you getting? Option D will be the correct answer. Then next question. Heat pump working on a reverse Carnot cycle. A heat pump has a COP of 5. So what is the value of COP of heat pump? COP of heat pump is nothing but 5. So write down COP of heat pump. COP of heat pump is equal to 5. It works as a refrigerator. म्हणजे तोच सेम heat pump जर as a refrigerator म्हणून वर्क करायला लागला. A heat pump working on a reverse Carnot cycle has a COP of 5. COP of 5. If it works as a refrigerator, taking 1 kilowatt of work input, the refrigerating effect will be. म्हणजे तो जर हीट पंप ऍज अ रेफ्रिजरेटर म्हणून वर्क करायला लागला तर त्या रेफ्रिजरेटरची सीओपी किती असणार आहे? आपल्याला काय माहित आहे? सीओपी ऑफ हीट पंप इज इक्वल टू सीओपी ऑफ रेफ्रिजरेटर प्लस 1. राइट डाउन द इक्वेशन. COP of heat pump is equal to COP of refrigerator plus 1. So we are knowing the value of COP of heat pump as a 1. COP of heat pump as a 5. So COP of refrigerator will be equal to 5 minus 1. That is nothing but 4. So that will be the value of COP of heat pump. Sorry, COP of refrigerator. So COP of refrigerator is nothing but 4. But what they have asked us? They have asked us the refrigerating effect. So as we are knowing the formula, COP of refrigerator is nothing but equal to refrigerating effect divided by work done. COP of refrigerator is nothing but equal to refrigerating effect divided by work done. Out of that, we are knowing the value of COP of refrigerator. What is the value of COP of refrigerator? 4. Refrigerating effect, that value we have to find out. Value of work done is nothing but 1 kilowatt. So put the value of work done as 1 kilowatt. So automatically the value of refrigerating effect will be equal to 4 kilowatt. Are you getting the answer? So 4 kilowatt will be the correct answer. Option B. समजतंय का इथपर्यंत? हॅलो, सगळ्याला समजतंय? Okay. Then next one. The highest temperature during the cycle in vapor compression refrigeration system occurs after. What is the highest temperature? TCRS सिस्टीम मध्ये हायेस्ट टेम्परेचर कोणत्या डिव्हाइस नंतर ऑब्टेन होतं? आफ्टर कॉम्प्रेसर. So option A will be the correct answer. After compressor. Then next one. Reversible engine has ideal thermal efficiency of 30%. So here also you require the pen and paper. So write down efficiency of heat engine. 1 minute. Write down efficiency of heat engine is equal to 30%. 30% means 0.3. 30% means 0.3. When it is used as a refrigerating machine with all the condition unchanged, the coefficient of performance will be. The coefficient of performance will be. So we are knowing the correlation. Coefficient of performance of heat engine, COP of heat engine, is nothing but reciprocal of efficiency of heat engine. Sorry, COP of heat pump. COP of heat pump is nothing but a reciprocal of heat engine, or a reciprocal of efficiency of heat engine. So efficiency of heat engine is nothing but 0.3. So as we are knowing the value of efficiency of heat engine, so write down COP of heat pump will be equal to reciprocal of heat efficiency of heat engine means 1 upon 0.3. 1 upon efficiency of heat engine. So 1 upon 0.3 is nothing but how much? 1 upon 0.3 is nothing but 10 upon 3, which is nothing but 3.33. That is the value of COP of heat pump. That is the value of COP of heat pump. But they have asked us find out the value of COP of refrigerating machine. So as the value of COP of heat pump is equal to 3.33. So COP of refrigerating machine is equal to COP of heat pump minus 1. COP of refrigerating machine is equal to COP of heat pump minus 1. So answer will be 2.33. 3.33 minus 1. 2.33. समजतंय का हे? कारण की बऱ्याच जणांचं हे आन्सर चुकीचं आलेलं आहे. Have you understood the concept? Have you understood? Shall I repeat once again? Hello. Shall I repeat once again? Here, which point you have to remember? Which point you have to remember? You have to always remember that COP of heat engine, sir, COP of heat pump is always equal to reciprocal of efficiency of heat engine. COP of, if you are not written, write down somewhere, COP of heat pump is equal to reciprocal of efficiency of heat engine. So here we are knowing the efficiency of heat engine as a 30%. 30% means that is nothing but equal to 0.3. That is nothing but equal to 0.3. So here, as we are knowing the formula as a COP of heat pump is equal to 1 upon efficiency of heat engine. So efficiency of heat engine is nothing but 0.3. So 1 upon 0.3, the answer will be equal to 3.33. So 3.33 is nothing but the COP of heat pump. But they have asked us find out the COP of refrigerating machine. So COP of refrigerating machine is nothing but COP of heat pump minus 1. So COP of heat pump is nothing but 3.33 minus 1, which is equal to 2.33. So answer B will be the correct answer. Have you understood? Yes or no? Okay. The next one, effect of superheating on the COP. Effect of superheating on the COP. So we are knowing that because of superheating, the refrigerating effect is also increases, as well as work done on a compressor is also increases. But rate of increase of a refrigerating effect is lower as compared to rate of increase of compressor work. Hence, the net effect of superheating will be to decrease the value of COP. So COP is always desirable up to 5 degrees centigrade. Above that, it will not be desirable. So why we are keeping this? Sorry, superheating is always desirable maximum up to 5 degrees centigrade, because it will ensure that 100% vapors are provided to the compressor. So here, effect of superheating on the COP will be to decrease the COP of PCRA system, not to increase. Then next question. What is the pressure and state of the refrigerant in the suction pipe? So pressure and state of refrigerant in suction pipe. Suction pipe म्हणजे बिफोर कॉम्प्रेसर. बिफोर कॉम्प्रेसर काय असतं आपल्याकडे? कॉम्प्रेसरच्या अगोदर काय असतं? पेपर्स असतं, पण कोणत्या प्रेशरचं असतं? लो प्रेशर पेपर. So option B will be the correct answer. Option B will be the correct answer, low pressure paper. Then next, what are the 4 basic component of refrigeration system? आपल्याला माहित आहे कोणते 4 कंपोनेंट आहेत. एक म्हणजे कॉम्प्रेसर, कंडेन्सर, एक्सपान्शन डिव्हाइस. एक्सपान्शन डिव्हाइसला तुम्ही कॅपिलरी ट्यूब पण म्हणू शकता किंवा मेटरिंग डिव्हाइस पण म्हणू शकता. आणि लास्ट वन इज नथिंग बट इव्हॅपोरेटर. तो हे चारही पण कशामध्ये? ऑप्शन डी. Option D is the correct answer. Then next question. In a typical system within which component would the evaporation of refrigerant takes place? आपल्या PCRA सिस्टीम मध्ये कोणत्या कंपोनेंट मध्ये इव्हॅपोरेशन ऑफ रेफ्रिजरंट टेक्स प्लेस? कोणत्या कंपोनेंट मध्ये होतं इव्हॅपोरेशन? कोणत्या कंपोनेंट मध्ये होत असतं नेहमी? In which device the evaporation of refrigerant takes place? कंडेन्सर मध्ये होतं का इव्हॅपोरेशन? नाही. रिसिव्हर किंवा ड्रायव्हर मध्ये? नो. कॉम्प्रेसर मध्ये इव्हॅपोरेशन होतं का? नो. So evaporation will take place in the evaporator. Then next one, answer. So the question is, I think this is the not correct question. So one, two, the process in which refrigerant is recycled to remove impurity, mobile refrigerant unit, the process by which refrigerant moves through a compressor, the process by which circulating refrigerant absorbs heat in one location and moves to another location. Okay, I think the question is the meaning of refrigeration is the process by which circulating refrigerant absorbs heat in one location and moves it to the another location. So I think the question was refrigerant means, or refrigeration means the process by which circulating refrigerant absorb heat in one location and move to the another location. I think D option will be the correct. So question might be the refrigeration means. Next one, in what part of refrigeration system does the refrigerant change from hot high pressure paper to hot high pressure liquid? हाय प्रेशर पेपरचं हाय प्रेशर लिक्विड मध्ये कशामध्ये कन्वर्जन होत असतं? नेहमी कंडेन्सर मध्ये. सो ऑप्शन बी विल बी द करेक्ट आन्सर. देन अ कॅपिलरी ट्यूब सर्व द सेम फंक्शन ॲज अ कॅपिलरी ट्यूबला आपण काय म्हणतो? इट इज नथिंग बट द एक्सपान्शन वॉल. द function of capillary tube will be as like expansion wall. So option C will be the correct answer. Small water line, wrong answer. Pressure relief wall or pressure relief line is also wrong. Bypass line is also wrong answer. In which direction does a refrigerant flow during a normal cooling cycle? कोणत्या डायरेक्शन मध्ये रेफ्रिजरंटचा फ्लो होत असतो? कॉम्प्रेसर टू कंडेन्सर होत असतो? यस. कॉम्प्रेसर टू इव्हॅपोरेटर होत असतो का? इव्हॅपोरेटर टू कॉम्प्रेसर होत असतो. कॉम्प्रेसर टू फिल्टर आउट ड्रायर होत असतो का? नाही. कंडेन्सर टू फिल्टर आउट ड्रायर किंवा रिसिव्हर टू फिल्टर आउट ड्रायर होत असतो. कॉम्प्रेसर टू द एक्झिट ऑफ इव्हॅपोरेटर, दॅट इज ऑल्सो रॉंग. सो option A, compressor to condenser is the correct answer. But compressor to condenser, where that is written, that is nothing but option D, compressor to condenser. The next question, define refrigerant or define refrigeration. It is the process of continuous cooling or extraction of heat to below that of atmosphere from a substance with the help of external work. That is option A is the correct answer. Below is the main component of refrigeration system except. या चारपैकी कोणता रेफ्रिजरेशन सिस्टीमचा कंपोनेंट नाही? पीसीआरएस सिस्टीमचा. तो कॉम्प्रेसर, कंडेन्सर, इव्हॅपोरेटर. ज्या ठिकाणी कॉम्प्रेसर असेल त्या ठिकाणी पंपची आवश्यकता नसते. तो इन केस ऑफ पीसीआरएस सिस्टीम पंप इज द ऑड ऑप्शन, because that PCRA system is consisting of compressor, condenser, evaporator and expansion device. 38. Below are the process in refrigeration system except. कॉम्प्रेसर मध्ये कॉम्प्रेशन होत असतं, कंडेन्सर मध्ये कंडेन्सेशन, पॉवर कशामध्ये असते? अँड इव्हॅपोरेटर मध्ये इव्हॅपोरेशन. सो रेफ्रिजरेशन प्रोसेस किंवा कोणती प्रोसेस, थर्मोडायनेमिक प्रोसेस कोणती नाही ह्यापैकी power is not the thermodynamic process which is occurring in the PCRS system. So option C will be the correct answer. Then second last question, I think the lowest temperature during the cycle in a PCRS system occurs after. सगळ्यात lowest temperature कुठं असतं? आफ्टर एक्सपान्शन वॉल असतं, नॉट आफ्टर इव्हॅपोरेशन. So option C will be the correct answer, because in the expansion wall there will be the expansion of the refrigerant, and because of expansion the lowest temperature will be achieved, and that lowest temperature refrigerant will be able to absorb the heat inside the evaporator, and because of which the lowest temperature can be achieved inside the evaporator. So option C will be the correct answer, expansion wall. And last question, The bootstrap air cooling system has how many heat exchanger? That will have the bootstrap, that will have the 2 heat exchanger. So last answer is nothing but B answer. So this was the test 1. Do you have any question related to this? Yes or no? If you are not having question, you have to solve. If you have not solved the test number 2, up till now 38 students have solved the test number 2. If you have not solved the test number 2, today only you have to solve the test number 2 up to 7 p.m. So after that, likewise today's result. So today also I have shared one Excel sheet. So that Excel sheet is consisting of your choice related to that question and whether that was right or wrong, and how many questions you have attempted, how many questions you have attempted correctly, and how many questions you have attempted wrongly. That analysis is done in that Excel sheet. Same way, another Excel sheet related to the test number 2 will be shared with you after 7 p.m. That means that I will share by tomorrow morning. So now time is 11:57. So one more important thing, don't write. So important thing that tomorrow is the last date for filling of the gate form. So everyone, you have to compulsorily fill the gate form. You have to take the screenshot of that gate form or filling of the gate form, and you have to send that screenshot to the your concerned project guide. So if you are going once after attempting the gate exam, and if you are getting non-zero score, that may be 0.1, 0.2 also, then also college is going to refund you 50% of the registration charges. So everyone has to fill the gate form today only if you are not filled. So now you can write roll number in the chat box and you can exit the meeting. Thank you.